Welcome to this platform. So in this video, let us have a look at simple machines. So I want to revise questions on simple machine, exam questions. Okay, so here is the first question that we are answering. The figure 4.1 shows a pulley system used to lift a load of 9,600 Newton using an effort of 2,400 Newton through a vertical distance of 20 meters. So let us take note of the information that is there in the first statement. The first question is calculate the mechanical advantage of the above pulley system. Now, before you even calculate the mechanical advantage, you need to know what mechanical advantage is by definition. So mechanical advantage is just a ratio of load to effort. Okay? Mechanical advantage is just a ratio of load to effort. So that is how you define mechanical advantage. Mechanical advantage, otherwise abbreviated as MA, is equals to load over effort. And since these are ratios, there are no units for mechanical advantage. And take note that load is in Newton and also effort is in Newton. These are forces. So let us find the mechanical advantage. So mechanical advantage in this case, the load is the one that is lifted normally, and the force that you apply is what we call effort. So force applied is called effort, and load is the force that effort overcome. So now in this case, let us look at let us replace in the formula. So 9,600 Newton divide 2,400 Newton. If we are to divide this, you can cancel out the zeros and just say 96 divide 24, and this should be able to give you a 4. So mechanical advantage in this case is a 4. So we've answered question A. What is the velocity ratio? Now when you are dealing with a pulley system, the velocity ratio just count number of wheels or number of strings. So number of wheels is easy to count because you can see them clearly. So 1, 2, 3, 4, 5. So the velocity ratio here VR is equals to 5. Okay, but you should know also that velocity ratio is also defined as the ratio of distance moved by effort to the distance moved by load. We are going to need this formula. So very important. So that is the velocity ratio on the second one. Then let us look at the C question. What is the efficiency of the pulley system? So efficiency, EFF, we can abbreviate it that way, is equals to mechanical advantage divide velocity ratio multiplied by 100%. So please take note that it's not always that you are going to use mechanical advantage divide velocity ratio to find efficiency. Sometimes you're going to need work done by load divide work done by effort, then multiply 100%. I guess you'll be able to go around that. Then here we have mechanical advantage, which is a 4, divide velocity ratio, which is a 5, multiply by 100%. And this one should be able to find 80% as our efficiency. At this point, you need to know a question why efficiency of a machine is never 100%, or perhaps you might need to know that question. And the reason behind that is that because most of the energy is wasted due to friction. So take note of that. Then calculate the distance moved by calculate the distance moved by effort. Now, to calculate the distance moved by effort, we are going to need the formula that has the distance moved by effort. And this is where we come to this part. So we're going to use velocity ratio is equals to distance moved by effort over distance moved by load. So velocity ratio in this case we said is 5 equal to the distance moved by effort is the one that we are looking for. But the distance moved by load, if you were to look at the formula from the information from the first, we are told that the pulley system used to lift a load of 9,200 using an effort of 2,400 through a vertical distance. So the vertical distance is the distance moved by load because we are lifting it up. So the distance moved by load is 20 meter, if I'm not mistaken. Yes, 20 meter. So here you just cross multiply now, of which you are going to have distance moved by effort is equals to 5 multiplied by 20 meter. And this should be able to give you 100 meter as the distance moved by what? Effort. Okay, and I guess you've gotten that. Let us have a look at the second question. The diagram below shows, which is B 3.1, shows a pulley system. The first question is that state the velocity ratio of the pulley system above. Okay, so the velocity ratio this is still the pulley system. You just count the number of wheels. So velocity ratio is equals to 2. Number of wheels, there are 2. 1. These are wheels that I'm talking about. So 2. Okay, but in number of string, you can count 1, 2. So you need to count the string that are attaching, not this one, but these that are attaching here. So counting the number of strings or wheels, you still find the same answer. Now, the big question is that if the efficiency of the pulley system is 75%, what is the mechanical advantage? So this time around, you are given efficiency, and of course, we are looking for mechanical advantage. To answer this question, we are going to look for the formula that connects efficiency and mechanical advantage, and that is the formula for efficiency. So efficiency is equals to mechanical advantage divide velocity ratio multiplied by 100%. You remember? So efficiency is given as 75 equal to mechanical advantage, which is MA, multiplied by 100, then divide velocity ratio, which is just a 2. So now we are going to have to cross multiply here, and we are going to have mechanical advantage 100 is equals to 75 multiplied by 2, which is just 150. So mechanical advantage 100 is equals to 150. Then divide 100 both sides, divide 100. You are going to find that mechanical advantage is equals to 1.5 without units. So that is how we work this one out. So this is our B. Then for question C, if the load is 120 Newton, what is the size of the effort? Now for this one, we are going to need also the formula that connects effort and load. Okay, and that is the formula for mechanical advantage. Mechanical advantage is equals to load over effort. Okay, do we have mechanical advantage? Yes, we just calculated it. So if you calculate the wrong one here, just know that even the next question, you are drowning. So 1.5 is equals to, what is our load? Load is given here as 120 Newton. Is it? Yes. Then divide effort. Okay. So here if we were to cross multiply, it to be 1.5 effort equal to 120 Newton. Divide 1.5, divide 1.5. And therefore effort is going to be, okay, how much is the effort? That is 120 divide 1.5. Be able to confirm. I'm able to find 80. This is a force, so 80 Newton. So that is how we work that one out. Then for the last question, the work done by effort if the load is lifted 0.5 meter. So how do you find the work done by effort? So this is just a fancy way of saying calculate work. Now work, you know that is force divide what? Distance. So the distance we are already given. All what we need is the effort as a force. You know that I told you from the start that effort is a force, and we just calculated here. Okay, so we are going to multiply. We are going to say force divide the distance. So the lifted distance is 0.5. So which means we are going to say 80 Newton multiplied by 0.5 meter. And what are we going to find? That is 80 multiply 0.5. So if we were to punch on the calculator, that is 80 multiply 0.5, we are finding 40. This is work joule. So that is how you work that one out. Otherwise, you've come to the end of the lesson. I hope you've enjoyed it. If you've not subscribed to this YouTube channel, consider doing so. Get to share with a lot of your colleagues, your friends, family. Get to tell also those that are writing next year that starting lessons is now, because there's no time. Okay, you barely have time. So only about 8 months remaining to the actual day of exams. And just to make you aware is that, or just to maybe in case you are not aware, the ECZ opened registration for GCE 2025 on November 1. So you have to register, make that decision and start learning. Otherwise, see you in the next one.